Hello students, and welcome to another how-to video. Today we're going to be writing chemical equations for combustion reactions. We have two problems here. We're going to combust acetone and hexane. So if we look here at hexane, we know that it's a hydrocarbon. Okay, that was in your vocabulary. You should know that term. It's basically carbons and hydrogens bonding and forming these long chains. And we have our usual culprits for combustion reactions, and that is oxygen to hydrogen. These are for combustion in our combustion reactions. And then we have our fuel. Our fuel will vary depending on what we're burning. It could be gasoline, it could be a candle, acetone. When we're working in the lab and we're using a Bunsen burner, it's going to be methane. Okay, so our fuel will change, but our rest of the equation will stay the same for combustion. So let's write this out. We have 6 carbon, and when we solve these problems, let's be specific. Okay, we have, we always want to start solving the carbons first, then the hydrogens, then the oxygens. That's our order in solving this problem. So if we have 6 carbons, let's add 6 carbons to this side. We have 14 hydrogens, so we're going to make 14 over here, but we have to divide it by 2, so it's going to be 7. So we're going to have 14 over here, and we're going to have 6 over here because we're going to balance this out. Then we add up the oxygens on the product side. So we have 12 plus 7, and that's going to give us 19. Okay, and that's going to be a hard number to work with. We can't divide this by 2 because oxygen is a diatomic molecule. If we divide 19 by 2, it's going to be 9.5, and we cannot have that. It's not going to work. So what we'll do is we'll have to double everything and then do it again. So we're going to double this. We're going to change our 6 to 12 and our 7 to 14. Okay, and then we're going to add up our oxygens again. 12 times 2 is 24 plus 14, and that's going to give us 8, and it's 38. And if we divide 38 by 2, that's going to give us a 19, I believe. Yes, it's 19. All right, now we're going to have 19 O2s. Okay, so this took a little more effort than original, easier problems because we had to figure out how to get our half into a whole number. Okay, because we can't have half an atom. We can't just have 9.5. It's just not going to work. Okay, so this is a balanced equation for hexane. Now let's do acetone. Now acetone is an alcohol because if you notice it has an O on the end because this one doesn't have an O. All right, so let's draw this one out. So we're going to have acetone, which is going to be C3H6O, okay? And we're going to combine it with oxygen, okay? Acetone is basically fingernail polish remover, you didn't know. And basically it doesn't combust with oxygen readily. We have to add energy. And I'm going to be more specific, and I'm going to say heat. We need to apply heat to the problem to get these two things to combust, the fuel and the oxygen. And it's going to form CO2 and H2O. And how many carbons do I have? We have 3 and 3. We have 6, and we're going to have 3 H2Os on this side. And then we're going to have to figure out our oxygen. So we have 3 times 2 is 6 plus 3, and that's equal to 9, right? Oh wait, we got an odd number again because we can't divide it by 2, but if you look closely, one of those oxygens is over here. So if we have to make 9 oxygens, one's going to go there, and then the 8 are going to go over here, and we can divide 8 by 2. So it's going to be 4. So that's a balanced equation. We now have acetone with 4 oxygen atoms combining with heat to form 3 molecules of carbon dioxide and 3 molecules of water. Okay, and if you want to be more specific, acetone's a liquid at room temperature, water's a gas, CO2's a gas, and because it's combusting and it's applying a lot of heat, water is most likely going to be in a gas phase. But if you let it cool down, it will eventually turn into a liquid. Okay, I think that's it for this video. Thanks for watching.